Okay, today is day 12, I think, of grinding Leetcode. This is a series of video where I find a Leetcode easy problem and trying to solve it within 15 minutes. If I can't solve it within 15 minutes, then I'm going to try to look at the solution and figure it out. So I have until now, until 10:40, I think. So I'm going to shuffle through here and get myself an easy question. I don't know why Leetcode is always this slow. All right, let's see. Number of arithmetics triplet. So I always find it very helpful to look at the explanation, the input and output before I look at um, the description. So what that's what I'm gonna do. So input nums 0, 1, 4, 6, 7, 10. So immediately this looked like it's sorted, and this looked like it's sorted, and the difference is 3. Okay, and the output is 2. So let's see. 1, 2, 4 is an arithmetic triplet because both 7 minus 4 is 3 and 4 minus 1 is 3. 2, 4, 5 is an arithmetic triplet because both of them 10 minus 7 is 3 and 7 minus 4 is 3. Okay, so it looking for a diff of 2. So this is immediately this look like a sliding window question. But let's see. 2, the output is 2. Okay, so this looked like a sliding window type of question here. 0, 2, 4 is an arithmetic triplet because 2, 0, 2, 4, so that's 0, 2, and 4. What? Where do you get 0 from? 1, 3, and 5, it's an arithmetic triplet because both 9 minus 7. 1, 2, 4. 1, where's 2 in here? 1, 2, and 4? How do you get 1, 2, and 4? You are given a 0 index strictly increasing integer array nums and a positive diff. A triplet 1, I, j, and k is an arithmetic triplet if the condition follow I less than j. The number at j minus the number I is equal to diff. The number of k minus number of j. Yeah, but how do you get 1, 2, and 4? I don't see a number 2 in here. Okay. The number of j, I, j, k. So I need to be less than j, needs to be less than k. So I need to be the first number. The first number is a 1. The second number is j, and the third number is k. Third number is k. K is 4. But where is 2? 0. I don't see a 0 in here. Oh, hang on a minute. Number at 1. Number at 1, so 0, 1. That is 1 and 1, 2, 4. Wow. Okay. Hmm. 7 minus 4. So that's 7 minus 4. So that's 4. 7 here. 7 minus 4, 2. Number 2, 0, 1, 2. 2 is 4. And that's equal to 3. Okay. I see how this work. So what I'm going to do is I'm going to store everything inside of a hash map. So this number, the number at this index minus is 4, right? Diff is equal to 3. But it's asking for triplet, arithmetic triplet. Does that even matter? I can put everything inside of a hash map so that it's like true sum, right? You put everything inside a hash map. If diff is in hash map, then that number is true. So that's what I'm going to do. Okay, this is definitely a hard one. What are hints? Are all the constraint small enough for a brute force? Maybe not. We can use 3 loop, each iterating through the array, going through the possible triplet. Be sure to not count duplicate. Okay, if I brute force this, num at length, it can be 200. So 200 to the cube is going to be ginormous. So I don't want to brute force this. I can do a for loop and brute force this. I could do 3 for loop and do brute force this. But I don't want to brute force this. So I can store the index of every single one of these inside of a hash map. And I can iterate through, take 10 minus 3, 10 minus 3, 10 minus 3 is 7. Is 7 inside of a hash map? Yes. Is 7 also less than, is the index of 7 less than the index of 10 currently number? Yes. Okay, so that's one valid number. Now continue until you find another one. Did you find another one? True. Okay, now continue. Now increment the pointer. So like it's gonna be a 2 pointer. So 0 plus 3 is what? 0 plus 3 is 0 plus 3 is 3. Is 3 inside the hash map? No. Go on to the next one. 1 plus 3 is what? 1 plus 3 is 4. Is 4 inside of a hash map? Okay, cool. 4 is inside of a hash map. Is the index at 4 more than the index at 1? Yes, that is true. Now continue until you find another one. Cool. Let's go on to the next number. So plus 3 again. I plus 3 plus 3. Cool. Okay, now take 4. 4 plus 3 is what? 4 plus 3 is 7. And 4 plus 3 is 7. 4 plus 3. 4 plus 3 is 7. Is 7 inside a hash map? Yes. Okay, now continue on. Now let's go on to the number 2, number 4. 4 plus 3 is what? 4 plus 3 is 7. 7 exists. Okay. Now is 4 plus 3 is 7. Does 7 exist? Yes. 7 plus 3 is what? 7 plus 3 is 10. Does 10 exist? Is 10 less than I? Yes, that's true. Return true. Okay, so that's what I'm going to do. I'm going to store every single one of these inside of a hash map. And then I'm going to iterate through in every single one of these and return the triplet. So let's do that. But how can I cache this to make it better? I can definitely make this more efficient, but I'm going to see if I can do it a less efficient way first. Like it's still going to be O of n, but it's going to be less efficient. O of n times 3. So do that first, and then I'll try to optimize it a little bit more. So first thing I'm going to do, for I, hash map is equal to this. For I, comma each, I, comma num n in enumerate nums, hash map at n is equal to I. Zero is 0, 1 is at 1, 4 is at 2. Okay, so that's what I got. Now what I'm going to do now is I'm going to loop through the first hash map. So for I, for n in nums, for I in range of nums, let's do n is equal to length of nums here. For I in range of n. Okay, so now we can do for I in range of n if cur plus equal to 1, cur is equal to nums at I. Nums at I, if nums at I, if num at I, if nums at I next is equal to next next num is equal to next num is equal to cur plus equal to I plus equal to 3 if next num in hash map and I is less than hash map at next num. So if this is false, it's going to break out of it. So if it's true, then check to see if I is less than a number at hash map. Okay. Now it's hash map. That's the first condition. That's the first condition. We're going to have a counter here. Counter equal to 0. Okay. So it's asking for triplet. So I can do a while loop here, or I can just do another one here. Next num. So now next num equal to next num equal to next num plus 3, right? Now if next num in hash map is also in hash map and I plus 3 and j is equal to I initially, right? So then next num, if hash map at next num, then you do this, j is equal to hash map at next num. That's going to give me the index, and j is less than hash map at next num. Then counter plus equal to 1. In the end, we're going to return counter. Let's see if that works. Arithmetic triplets. What's wrong with this code? J is equal to I. Hash map at next num. This is completely valid. What's wrong? Key error. Okay. Now we're going to print out. Let's print out hash map. Because that's going to give me the index of j for sure, right? Now we're going to print out hash map. Let's see. Hash map 0, 0. Okay. 0, 1, 1, 1, 4, 2. Cool. Now what's wrong with print hash map at next num? Next num plus 3. Excuse me. Next num plus 3 plus diff. Plus diff. That's why. Four and 5. If next num in hash map and I is less than hash map, next num, then go in here. So 4 and 5. 4 and 5. Okay. So that's the first case. Now print out counter. Okay. Okay, counter is 0, 0. So this is the first iteration. 4 and 5. It never got into here. Next num is equal to cur plus diff. So cur plus diff prints out. Cur. Wait, cur at num at I. 0, 1, 4, 4. 0, 1, 4, and 4. 0, 1, 4, 4. No. Okay. Cur plus diff. Cur plus diff. Diff is 3. 4 plus 3. It's 7. Okay. I'm nearing the end here. I'm having a off by 1 bug that I'm trying to solve. What is wrong with this damn thing? Print hash map. Next num in hash map. In hash map. And okay. Why don't we do that? Next num is equal to next num. Before next num. Before and after. Before is 4, after is 7, before is 10, after is 13. Okay, yeah, 13 is definitely not in there. Okay. Ah, I see. Hash map. Okay. So J need to be initialized inside of this. J need to be initialized inside of a second loop. Next num is going to occur at diff, so that's fine. Boom, boom. So I don't think I need to increment it twice again. Okay, J going to return counter. That should work. List index out of range. How do I even break it out here? Cur at nums at I. Cur go num at I. Under n minus 1. Am I doing that now? No, that's not the case. Print I. And 0, 1, 2, 3, 4, 5, 6, 6. Nums at I. Nums at I. 6. Okay. 0, 1, 2, 3, 4, 5. Nums at I. N minus 1. Just 0 to 5. What? N minus 1. For I in range of nums at. Oh, hang on a minute. I know why. Right here. Because this is overriding it. And that should work. Output 0, expected 2. Okay. So we are printing out J here. J here. Two, 4, 5. Okay. So 0, 1, 2, 2. J is equal to hash map as next num. course J is going to be hex map. Next num. And then next num plus equal to diff. Next num plus equal to diff. There we go. Okay, that will work. Okay, holy shit. Did I just beat like 93%? Holy shit. I just beat 97 point, okay. Solution. Holy shit. Okay. The other one is, yeah, even my solution beats the fastest solution. What? Okay, that's crazy. Because this is basically, you can probably cache this actually. Why is the damn thing so slow? There's no way. There's no way mine is the fastest. There's no way. Oven, coordinate Python user approach. All right, let's see how fast this is. Let's see how fast this other solution is. 2 pass. Oh, that's Java. Jesus. This is going to be the one here. The fastest solution. I mean, this is definitely a lot cleaner than the other one. Insane. Okay, that's still pretty fast. All right. I'll give you that. All right. Wait, hang on a minute. Let me run it again. What if mine is faster? Okay. Submit. Is mine consistently faster than his? Okay, it's 40 milliseconds. That's fine. Beat 90%. That was insane. All right, let's run it again. Hopefully I can get a better score this time. Give me a 30. 42k, fuck. All right, fine. I'll take that. The rest of these. Oh, okay. So the even distribution is like way up here. How can I make this faster? I can probably cache the previous solution, a sliding window, with a left pointer and right pointer. So what if we have free pointer? Left, right, left, center, and right, right? If we have, we just need to check this third pair to see if it's great. So that way we don't have to do the repeat calculation part. What do we have 3 counter? What do we have 3? Okay. No, we still need the hash map because that's going to be constant time lookup. Okay. Let's call this length. It's equal to nums length minus 1. Okay, so now we have left, right, and center equal to 0. Print left, right, center. It's gonna throw an error. Left equal to right, right equal to center equal to 0. How about that? Okay, so we have all 0. Now we're going to move the first pointer. While left or right is less than length, we do this. Left if nums at left if num's at left, if num's at left, time num's at left, num equal to nums at left, nums at left, right num equal to nums at right, num center num equal to nums at center. Okay, so we only want to check the rightmost num, right? Okay. Nah, on second thought, this might not be the best solution. Anyways, have a good day, have a good life, and goodbye.